Still morning, right? Just barely. How are we? I hope you're enjoying this NDC event. I am so happy that NDC has come to the United States. I've been doing NDC events for years in Europe, and I always thought they were one of the best conferences around. So I was really happy and honored to be part of this event. So today's topic is an opinionated approach to ASP.NET Core. This is basically where I sat down after a couple code reviews and said, you know, we're doing some interesting things in these projects, and I'd like to jot down some ideas of things that we've done right and things that we've done wrong. And I came up with a list of something like 61 items, and I thought, well, if I can cut it down to an even 50, maybe I could make a conference talk out of it. So that's what you're going to hear today. We're going to cover topics like organizing your solutions and projects, organizing your startup code, working with controllers, working with Razor pages also, how to organize client code, a couple tips for writing C# code in the .NET Core environment, and working with views and Razor pages. So I do assume that you know a little bit about ASP.NET Core. Maybe you're already working on a project, maybe you're planning to start a project, and if so, I hope that these tips help you. So we'll start about solutions and projects first. Oh, also some testing tips. Some of my personal philosophy and maybe some rants towards the end. Solutions and projects. You know, there's this really interesting thing if you go out onto GitHub and you look at project structures, how things are laid out inside of a GitHub repository across various technologies, across Node and across Ruby, and people that are doing pure SPAs and Microsoft repositories for .NET Core code. You'll start to notice a consistent project structure that I've adopted for my project. So if you look at pretty much, well, if you look at any Microsoft repository related to .NET Core or ASP.NET Core, you're guaranteed to see a few things at the top level of that project, which is you're always going to see a source folder. Underneath of there, I know that all of the CS proj files, all of the projects that make up this solution, this NuGet package, whatever we're putting together inside of this repo, they're all going to live inside of there. There's always going to be a test folder where all the unit testing projects live. If this repository represents some sort of library that people are going to use, there's typically a samples directory that shows you a few different ways to consume this library and work with the APIs. There's typically some build scripts checked in at the top level. There might be some benchmarks if it's a performance-sensitive piece. And I like this repository structure. It's something I've adopted for my projects. It takes a little bit of work inside of Visual Studio. I'll give you a tip for that in just a second. But if you can mimic that repository structure inside of Visual Studio, when I actually look at the solution inside of Visual Studio, it encourages developers to follow that structure. So docs might be another top-level folder that you have for a project. Of course, one challenge to this is that we know that the Solution Explorer in Visual Studio is a complete fabrication of what actually exists on disks, right? The Solution Explorer lies. It doesn't actually show us the physical file system layout. But, and what do I mean by that? I mean, if I come into, don't do this auto advance on me, please. This is not a PubConf presentation. If I come into Visual Studio and I'm looking at the regular Solution Explorer view, and I tell this to add a new folder, that's not adding a folder on my disk. Where are we here? Have to back out a little bit. Adding a new solution folder creates a virtual folder that the solution file understands, but it doesn't create something on disk. So I can create this new solution folder. It's not going to show up in the file system. It's not going to show up in my repository. I can add items into it, and they're just going to be dumped into the root of the project. However, Visual Studio 2017, up here in the action toolbar of Visual Studio, of the Solution Explorer, there is this little thing to switch over into a Solutions and Folders view. And when I click on that, now I have a view of the file system, just like what I would have in Visual Studio Code. It's presenting the truth. So if I right-click a folder and I say, please add another folder, it actually adds something to the file system, that folder. So it has some advantages and disadvantages, and you might find yourself toggling back and forth between the solution view and the folder view. The folder view is great when you want to create a folder on the file system, you want to add some files to it. So here I have a scripts folder, which I'll talk about in just a bit. I encourage people to add scripts to their project and check them into their repository. But some of the things I lose, like if I try to right-click on a project If I like right-clicking to manage NuGet packages and right-clicking to do different things with my project, all those project options are gone because now it's just kind of a folder. But you can toggle back and forth depending on what you want to achieve at the moment. So I can right-click now and get to manage NuGet packages. Some other things that you might consider checking in include samples and tools. So here's the great thing about Microsoft open sourcing things. There was never a problem if I wanted to see the Microsoft source code for, let's say, system.string or something that was built into the .NET framework. There was always decompiler tools that I could use to dig into code that they wrote for ASP.NET or anything. So having that code now be open source on GitHub, yes, it's an advantage. I don't have to work quite as hard to see the code that they wrote. The big advantage to me is the other things that you find inside of those GitHub repositories for ASP.NET Core and .NET Core and CoreFX. The samples folder. So when I was trying to understand ASP.NET security and what was happening at a lower level, I went into the GitHub repo, ASP.NET/security, and I found the samples folder. And lo and behold, inside of there were just these somewhat thrown together samples of things you would never do in production, but they were very revealing of how the middleware and how the services worked for things like ASP.NET cookie authentication. So you dig into the cookie sample and you'll see an example of different configuration options and what the middleware is supposed to do and what it's not supposed to do. The other thing that is extremely valuable inside of those GitHub repositories are the unit tests, because again, you can read through the unit tests and find testing tips from Microsoft. How do they test stuff like middleware? And also you can look at what a service and what a piece of middleware is supposed to do by reading the unit tests. So those are all very valuable and things we didn't have access to before. I also like to include development scripts. So with .NET Core, we have a command line interface that can do all sorts of interesting things. We can use it to add package references, and with the entity framework, it can create migrations, update databases. If you're developing for some sort of cloud platform like AWS or Azure, it's very useful to have scripts checked in so that when developers clone the repository, they'll know that there's a script in there to set up a development environment, for example. It'll go out to Azure and set up an app service and a SQL database and give it some default parameters for them to start working. So I always include development scripts. Oh, and one other thing, the solution file, the .sln file, it's nice to keep that in the root of the repository. That way I can clone a repository and just double click that right away. I don't have to go searching for it and I can open up the solution. But here's an example of an add migration script that is checked in. So a developer can just say, add migration, add employee feature, or edit invoice feature. And what that will do is go over to the data project, run EF migrations to add a new migration, automatically update my database, and then put me back into the folder that I was in before with a pop. So it just kind of makes things a little bit easier. Deployment scripts and templates. Depending on what cloud environment you're working in, there's various different ways to approach the provisioning of a development or a QA environment. I use Azure quite a bit. So one of the things that we'll do is usually check in a script file that you can run that will execute an Azure Resource Manager template, which is a JSON file, which includes all the configuration information for setting up a resource group. In fact, in Visual Studio, there's resource group projects that you can create that will automatically generate some PowerShell scripts for you and some templates that you can modify inside of Visual Studio to like set up an app service, set up a SQL server, set up an Azure Key Vault, wire up all the configuration settings. They look kind of like this. This would be an example of going to the automation script inside of the Azure portal and say, generate for me a resource manager template that I can then check into source control, and that resource manager template describes the resources I have created and all their configuration entries. Unfortunately, they're frustrating to work with. Anyone use resource manager templates? Yeah, a couple, yeah. It's amazing, you can go into Azure, you can set up, let's say, a virtual machine or an app service, you can do these things, then you can come to automation script and you can have Azure generate the script that is supposed to create that resource, and in my experience, they only round trip about 80% of the time. Sometimes you have to go back in and tweak things, and the documentation's not that good, and you get strange error messages. But when things are automated and they're working well, it's a truly wonderful experience. Another option for Azure would be the Azure CLI. It can create virtual machines and delete virtual machines and SQL servers and app services. So we check them in. What about builds? Some of the projects that I create use AppVeyor, which basically gives me a free build engine for open source projects. If I have something out there where I want to create a NuGet package, inside of AppVeyor, I can tell it where in GitHub is the source code that it should pull down when I do a push or a pull request. Where's the source code live that it should pull down? And then I give it build instructions. And I can either describe the build instructions in a UI by selecting checkboxes and saying do this and do that, or I can check in a YAML file. So my general recommendation when you use these build systems that try to be GUI driven is to get as much out of the GUI as you can and try to put it into scripts or some sort of configuration file. So for example, with AppVeyor, if I check in an appveyor.yaml file into the root of my repository, that gives AppVeyor all the instructions it needs to do a build. And one of the things I can tell it when it does a build is to use a build script that I also have checked in, so build.ps1. Typically, .NET Core applications are pretty straightforward to build. This would be an example of a PowerShell script that basically does .NET Restore, .NET Build, .NET Run the tests, and then .NET Pack to create the NuGet package. So the advantage to this is if a build is not working in AppVeyor, and I don't have a script, I'm just relying on the AppVeyor UI to do things for me, it's very difficult for me to debug. I can't run the AppVeyor build locally. At least with this, I can run this PowerShell script locally on my machine, and it should produce the same result as when it's inside of AppVeyor running. Same thing goes for VSTS. So if you use Visual Studio Team Services, you're probably aware that you can create a build definition, and inside of a build definition, you can drag and drop these different tasks and arrange them and configure them to do the same things that we just saw in the PS1 script. So do a .NET Restore, do a .NET Build, .NET Test, .NET Publish the artifacts. Some of those steps are not things that you can easily replicate in a local development environment, things like publish the web artifact, because that's actually taking a zip file and putting it into VSTS somewhere where you can download it later. But certainly, .NET Restore, .NET Build, .NET Test, .NET Publish, not necessarily I need something I don't necessarily need to describe those steps inside of a GUI. So an alternative would be to use from the task catalog, a simple PowerShell task or command line task, or custom tasks that you can get from the VSTS marketplace that know how to run build scripts like Pisaki or Cake. Cake, if you haven't heard of it, gives you the ability to write C#, to write build definitions, to write build tasks using C# code, so it's familiar. And you can run that same Cake or Pisaki or command line script on your development machine and also inside of VSTS, and that makes your builds a little bit easier to debug, as well as source controlling what's actually happening. So let's get out of some of the mundane stuff and talk about startup code. So in doing code reviews, when I open up a project, one of the first places I'll look is inside of startup.cs, because we know that for ASP.NET Core, that's what defines what services are going to be registered with the ASP.NET Core container. That describes what middleware is in effect for doing HTTP processing. And to me, that's all startup.cs should be responsible for. It basically describes how is the application going to behave at runtime. But when I open up startup.cs, sometimes I see some of the most bizarre things that people are doing. I've seen people seed databases and run database migrations and move files around on the file system, make sure their CSS files are copied out of some folder and put into www.root, things like that. To me, there's better places to put that kind of logic if you insist on having that logic inside of your application. And we'll talk about where that is. But to me, there's three responsibilities inside of startup.cs. There's the constructor. You can do some limited work inside of the constructor if you want to inject some services like the hosting environment or iConfiguration and save that off as a field to use later. There's configure services to configure the service provider, aka the container inside of ASP.NET Core. And there's configure, where you can receive an app builder, as well as other injected dependencies to define your middleware. That's all you want to do. So in ASP.NET Core 2.0, if I open up program.cs, I actually like to get as many things out of the way as possible before we even get to the startup constructor. So if you want to configure some logging and things like that, that would be best to do inside of the main method. In fact, if we look at a different project here, program.cs, maybe you know by now, but you scaffold out an ASP.NET Core 2.0 application. This create default builder does a number of things for you, including setting up some default application configuration sources. So it goes ahead and registers appsettings.json and appsettings.development.json as configuration sources. It also configures Kestrel. It also configures a console logger. So if anything goes wrong, things spit out into the console. A lot of this stuff like that, logging and so forth, is taken care of for you before you even get into startup. So to me, startup these days is really about two things. First of all, there's services. So inside of configure services, I have sometimes seen hundreds of lines of code because people want to use the MVC services but customize them a bit. So they'll add some code to do things maybe like this. So 10, 15 lines of code to customize some of the MVC options, to add different conventions, to change view locations and so forth. But you can imagine if there's this block of code to configure the MVC services, and then you add some additional code inside of configure services to configure entity framework and to configure ASP.NET identity. Configure services becomes very cumbersome to look at and try to figure out what's going on. So I always encourage people to keep this method flat. All I want to see is a list of things that you're doing. Oh, you're adding MVC, you're adding some security services, you're using Mediator, you're adding some data stores. And if I'm interested in some specific details, like what are you doing to customize MVC, I can just put the cursor on that line, press F12, and I can look at exactly what you're doing. But this is a good big picture view, which is what I want to see inside of configure services. I don't actually want to see all the little configuration details. Same thing for configure, which is setting up middleware, although I do believe it's okay to have an if-else statement inside of there. So I just want to be able to see, oh, you're in development, so we'll use the developer exception page and database error page and browser link, which no one uses anymore, I don't think, but it's on the slide. Otherwise, we use this exception handler, and then there'll probably be a string of middleware beneath that. And again, most pieces of middleware allow you to pass in options to specify some different behaviors. For example, the static files middleware, I can pass in options to tell it what physical directory to look in and so forth. But if I'm going to have any of those options inside of configure, again, I want to write an extension method for iApplication Builder so I can just see something that says use static files with options, right? And those options are tucked off as details somewhere else, and I can see exactly what middleware is in the project and what order that middleware is executing. And then what about all this other stuff? So what if you want to run entity framework migrations? What if you do need to copy files for some strange reason? What if you want to seed the database with data? Well, it's really interesting that ASP.NET Core, what we're creating is a console application. You know, if I do a .NET run, I am running a process from the console that's standalone. And what's interesting about that process is there's this point in time after I've asked the web host builder to build me a host, and before I call run, which is when it starts opening or listening for socket connections to come in and process HTTP messages, there's this period of time right in here where I have a fully configured application. All the services and all the configuration options that I've pumped into the application are there. We know about our app settings, we have our connection strings, we know what services we're going to use in production. And so if I want to execute some code at that point to do something like seed the database, then the main method of program.cs or somewhere inside of program.cs between build and run, that's a good place to call out and do things because I can take advantage of all this knowledge that I have. So here's an example. I want to process some DB commands looking at the incoming command line arguments and using my host so that I can get to services and connection strings and things that are configured. Here's a piece of code. Well, it might be easier to come over to Visual Studio and look at that. Here's a piece of code that'll basically say, okay, if someone did a .NET run on my application and passed in an argument drop DB, what we're going to do is use our services to get a DB context and make sure the database is deleted. And if they passed in drop db space migrate db, well, also did it get a db context and tell it to run the current migrations, which could even create a database from scratch. And if they also typed in cdb, we can add some initial data that's tucked away inside of the application somewhere. And I just want to point out that all of this is inside of a using statement where we get an iService scope factory and tell it to create a scope. And that's very important. If you're ever going to go directly to the service provider inside of ASP.NET Core and ask it to resolve a service, which is what happens down here. So, dear service provider, give me the DB context derived class so I can work with the database. If you ever do this outside of the scope of an HTTP transaction, you have to be very careful that you don't accidentally create a singleton, which is what will happen if you don't explicitly get a service scope factory, tell it to create a scope, which gives you back a service provider that you can use to resolve services, but when you dispose it, it can clean everything up, make sure that goes away. So how would this get used? Well, I could write a little script that a developer can do execute called recreate DB. So when I arrive to the office in the morning and I do a git pull to get the latest source code that people have checked in, I don't know if there's new migrations or new sets of test data or what is it. So I'll just do a git pull and then recreate DB, and it'll run my application, drop it, migrate it, seed the database, and then stop. It will not listen for sockets at that point. So that makes life a little bit easier. Let's talk about project structure. I have an extremely difficult time these days looking at a traditional ASP.NET MVC project that has a controllers folder and a views folder and a models folder. To me, it drives me insane. Let me show you, let me try to demonstrate that by, let's pretend for a moment. So over here, I have created a new project, Web Application 35. I'm about to do some work on it. We just came out of a sprint meeting and someone has told me that the register or the reset password, users are not able to reset passwords. And I need to go into this application and look at that bug. So this application was generated by doing file new project, asking for an MVC project, and setting the authentication options equal to individual authentication. So it's using ASP.NET identity, and it spit out a bunch of user interface code that allows users to register and log in and log out, change their password, reset their password, et cetera, et cetera. But now it's my responsibility to work on this feature, what everyone else in the company thinks of as a feature, to reset a password. So, let me start with the controller. Is it in the account controller or the manage controller? I don't know, but how bad could it be to just look through one of these? Let's start actually at the very top of this file, at line 1. Okay, here I can see we're going to log in with two-factor authentication. Maybe I just should have done a find in files. Lockout, register, external login. What's going on? Confirm email. Forgot password. Oh, here we go. All the way down here at line 392, reset password. This must be the area that I went to work in. Okay, so next, let me find the model that this is working with, because maybe the problem's something with the validation with the model. I guess that's in the models folder, so I have to come over here. I apologize if you can't see the Solution Explorer, but I found the view model. Okay, there's the view model. Now I have to find the view. So we have to jump over to the views folder, and fortunately, yeah, I can see under the account folder there is a reset password view, and finally, I haven't even got to the unit test yet, but finally I might be able to work on this bug where there's a problem with reset password. That just drives me insane. The model view controller design pattern tells us that we should have a separation of concerns between the model, the view, and the controller. The controller receives an HTTP request. The controller uses some services to build a model. The model doesn't know anything about HTTP, doesn't know anything about views. The controller takes that model, can hand it off to a view, and the view has the logic to render that model. So there's a separation of concerns, but no one ever said that there had to be a physical separation between the abstractions in that design pattern, where we had to put them into 3 different directories. So for the last, I'd say year and a half, I've been using a concept known as feature folders. So with feature folders, you can organize folders however you want. You might even organize it organize them hierarchically, like your UI is organized. So when I go into the application, there's an admin link, and I click on that, and there's a menu open that allows me to manage this and manage that and manage seasons. And oh, you know, now when I'm trying to work on a feature that someone has identified in the application, I'm kind of following the same logic when I navigate through these folders. And lo and behold, here's my controller. It's in that folder. I just open it up. There's some views associated with it. I can open that up. And there's some models, and they're all in the same folder. Still a separation of concerns, just not a physical separation of the abstractions. And to me, it's a much easier way to organize MVC applications and find things and work on things and actually work on features. This would be maybe how we could start reorganizing the account controller, breaking it out into smaller pieces and maybe having a reset password controller folder inside of here. To do this is very easy. I actually have a NuGet package, which is odecode.add feature folders. You can install that. Actually, the command you'd probably want to use today is .NET add package, odecode.add feature folders. And in configure services, you can just add MVC and then add feature folders to that service. It'll configure your MVC options to use those. That being said, these days I quite like Razor Pages. Who's using Razor Pages? Who knows about Razor Pages? Okay. When Razor Pages first came out, and I think many other people looked at it and said, oh, this is going to be one of those too simplistic things that Microsoft has come up with that I never want to actually use. But then, when I actually started digging into it, I realized Razor Pages are exactly what I want when I want to generate HTML. So I'm going to walk you through a couple Razor Page scenarios just to show you what I think are the advantages. But to me, if I'm building an API that has to return JSON or XML, I'm not generating HTML, I'm building an API, that's when I use MVC controllers. If I'm generating HTML from the server, I don't want a controller with a view, I want to use a Razor Page. So over here in Visual Studio, I just want to show you that as an alternative to Web Application 35 with all those huge 500-line controllers, and controllers and views are in different places, I also have Web Application 36, new and improved version of Web Application 35. But this one was generated using File New Project and selecting ASP.NET Core Razor Pages and individual authentication. So instead of generating huge controllers, it has now generated a series of Razor Pages. And now when someone comes to me and says, hey, there's a bug with the users resetting passwords, what are you going to do about it? What I will do after I close all these things up here, let's not save anything. What I will do is say, oh, let's go into Pages. I guess that would be under Account. And let me look through here. Oh, here's Reset Password, the Razor Page. Let me click to open that. And here's Reset Password, the code behind, or page model for that Razor Page. And ta-da, I now have everything open that I need to work on that feature. So to me, Razor Pages are a lot like feature folders. I don't need to use feature folders if I'm building stuff with features with Razor Pages. So what are they exactly? Yeah, so Razor Page is still just a Razor view, has a CS HTML extension, uses tag helpers, uses model binding, you can render sections, you can use layout pages, view start, all those things that you usually do with Razor views. The difference is it's going to have a page model or code behind file behind it, which some people think, oh my gosh, maybe it's too much like web forms, but it's not. There's still a separation of concerns, there's still dependency injection. So you can see when I need to reset a user password, I can have a constructor and ask for dependencies like a user manager or a logger or a DB context or iHosting environment. I'm not a big fan of this, but I can define my input model. I can define input models and output models and have this Razor Page work with them. When a user posts something to my Razor Page, I can tell ASP.NET Core that I want to try to receive posted form values into this property input. So that's how I can receive things like the user's email and their password and their confirmed password. The onGet method responds to a GET request. The onPost method responds to a POST request. There's no synthetic click events or any funny stuff like that. So to me, this is just as good as having a controller and using a controller to render a view, just things are organized a little bit differently. Plus, Razor pages have some advantages over controllers. Like one of the features they added to Razor pages is that they will automatically validate anti-forgery tokens on a form post. So you don't have to worry about developers accidentally forgetting the validate anti-forgery token attribute on a controller action. They will do that for me because they just assume everything's going to be a form post when there's a post. So Razor page is good. Give them a try. Controllers. I do not allow people inside of startup.cs to say app.useMVC and then write that little Lambda expression that takes a route builder and define routes inside of, the conventional routes inside of startup.cs. The conventional route would be something like controller/action/ the optional ID parameter. When people rely on those routes inside of startup.cs, they build horrible looking APIs. They don't think about the URLs. They don't think about parameter names. I want everyone, and I encourage everyone, to use route parameters. Because with route parameters, developers are much more likely to say, well, actually this piece of the API, it's part of the admin section or the admin feature of our API. So let me put a literal admin in front of this. So admin/manage something, and then some action perhaps. And I don't know if you've ever worked on one of those MVC projects where every single action parameter was named ID. Have you ever done that? Ever had that? Even if it was something like invoice date, right? Someone's passing in an invoice date and they'll still call it ID. Drives me insane. So the routing, the route attributes also encourage people to think about the parameter names and what they should be called and what they should be named for the actual action. So instead of having an ID, because I'm just being lazy and relying on the conventional route defined inside of startup.cs, I'm actually thinking, this is a season ID versus a match set ID, and my actions become a little bit clearer to me. So I encourage you to use the route attributes and throw away the other forms of routing. This one I was big on Mediator, and now I'm backing off a little bit on that. How many people use Mediator? Anyone? Few? It's a very simple in-memory message bus. What it allows me to do is inside of a controller action, I can remove pretty much all of my logic inside of a controller action, and instead what I want to do is put together either a command or a query. So in this case, I'm putting together a command, and that command is actually just based on the inputs that the user has typed into a form. I'm going to accept those inputs as a command, and I'm going to tell Mediator to send this command off somewhere in the system that's actually going to process it and produce some result for me. So all of the logic and the services and the things that go into logging in a user are completely removed from the controller. They're somewhere in a request handler that I've defined for that specific type, login user command. So the good news is that means some logic becomes a lot easier to reuse. It's packaged away inside of a component that's not coupled to your UI or to a controller at all. It's also easy with Mediator to introduce things like decorators. So if I want this command to flow through a pipeline, something that'll log it and something that'll validate it and then something that'll actually execute the login, that's relatively easy to do with Mediator, and I can plug things in. But that being said, there's always downsides, right? So a lot of people will look at it and say, that's just another layer of abstraction, and what you're doing is you're making it harder for me to work on the login user feature, because I don't know where that goes. So you have to decide based on your team and based on the type of application you're building and how much flexibility you need and how much reusability you need, whether or not to use Mediator, but it's good for specific scenarios. The other thing I tell people is don't build projects anymore that have an API, have API endpoints inside of it, and also have endpoints that render HTML and take form posts. At least don't do it if you're using any form of cookie authentication, because as soon as you have cookie authentication, you have the risk of a cross-site request forgery, and a lot of people don't realize that they have to protect from cross-site request forgeries in their APIs. So in order to do that, one of the things we have to do is get anti-forgery tokens down to our JavaScript so that when we make AJAX calls or use the fetch API, we can pass along an HTTP header that includes an anti-forgery token. And this is just a simple code example of an endpoint you could build that JavaScript could invoke to get the anti-forgery token that it needs to send along. So just inject the anti-forgery service. And what this GET request will do is use that service to get and store tokens. It's not obvious, but get and store tokens actually does two things. One thing it will do is return a data structure that has the anti-forgery token inside of it, and also has the header name that JavaScript should use when it sends that token along. So we will take that data structure and serialize it back and send it down to JavaScript so it can use that token and write the appropriate header. But the other side effect that happens here that's not obvious is that if the anti-forgery token cookie has not been set into the browser yet, when I call get and store tokens, iAnti-forgery, the default implementation of iAnti-forgery will issue that cookie. So at that point, I could start using validate anti-forgery token on my API endpoints. Typically not something you want to do. If you can separate them, you don't have to worry about that type of thing. Security policies. If you're just coming into ASP.NET Core and you're wondering how authorization works and how you can write authorization attributes to work with roles and Active Directory groups and things like that, excuse me, that could be an entire day workshop, an entire day of a workshop. But basically, everything in ASP.NET Core boils down to claims. So I can build a claims principal to define a user and add claims to that principal saying this is their first name, this is their email address, this is a role that they're in, like admin, or the department that they're in, which is sales. And once that is there, when I want to authorize that user to do something, I can look at claims. And these, again, so claims can represent roles, they can represent facts about me, they might represent permissions that I have. So a claim could be, can edit invoices, that could be a claim. And the way I evaluate claims, the easy way to evaluate those is to use an authorization policy builder. When I have a policy builder, there's a Fluent API where I can say require this, require that, and require a claim like is admin with this value. And when I build that policy, I can then use it and give it a name. And I could say authorize, that authorize attribute is admin. Or I could wrap it up into a custom attribute. User is admin. What that'll do is it's basically the authorized attribute saying evaluate the policy is admin, which checks for the claim is admin. So hopefully that's making sense. Security policies are very easy once you know that they're there and you know everything is working on claims. Talk about views for a second. Don't use HTML helpers anymore. They're hideous, and they were always the worst part of ASP.NET MVC. Use tag helpers if you're not already. So things like ASP-4, ASP-validation summary, those are good. They're easy to read. They're also extensible. You can build your own tag helper by deriving from a base class tag helper and implementing a process method. They're relatively straightforward for most trivial tag helpers. Use view components. View components are like partial views, but they get to render things independently. So a view component is like a controller in the sense that you can give it a constructor and you can inject services into it, but it doesn't respond to a request. It has to be rendered from some other view. So in a view, I can say, actually, this way, with a tag helper, I can say, go out and render the view component main menu. This main menu is a class with an invoke method. So it can have logic in there, it can do data access, and it can say return a view. And that view could be whatever markup you need with whatever model. And that's a good way to build composable UIs if you need to. Client-side code. So everyone's using some form of Angular or TypeScript or React these days, and my favorite tool to build that sort of thing is Webpack. I'm not going to go into a lot of detail on this since I think there's some other talks this week on Webpack, but this is an example Webpack configuration file. So the thing I wanted to point out about Webpack is I've seen a lot of developers struggle with that Webpack configuration file, and the trick is, don't think of webpack.config.js as a typical configuration file. It's not a JSON file. It's not static inert data. It's actually a JavaScript module that Webpack, the tool, will load up and execute. So you can put executable code in there if you need more flexibility. So for example, if I need Webpack to go out and find Typescript files that are kind of scattered across feature folders, I can actually write some JavaScript code that gets executed inside a node to say, let's go out and lob up all the TS files, specs.ts files, so these are unit test specifications, grab them from all the feature folders and put them into an array for me, as well as all the specs that are in this client folder. I'm not going to talk about JavaScript services that much. That was another Steve Sanderson creation though, but that basically allows you to use Webpack hot reloads integrated into ASP.NET Core middleware, so that when you send a request to your ASP.NET Core application, ASP.NET Core can work with Webpack to compile all your TypeScript files, bundle them into a JavaScript file, put them in the browser, and then as you make changes to your JavaScript and save it, those changes can be compiled and automatically swapped into the browser for you, the hot module replacement. I'm a big fan of conemu. Anyone use conemu or Commander? So once you start working with some of these command line tools and you're writing some command line scripts, you'll realize the basic Windows command line is sometimes a little bit deficient. So I use conemu. So a couple different things I can do here. One is I can right click and say create another console for me and have, it's hard to see here, but let me look down here at the bottom, tabbed consoles, which is very useful when you have a long running task in one. I can also do things like this. See if I have it set up to work today. Where are we? GitHub, be released scripts. Yeah. So I just typed js.command because inside of this project there's a bunch of things that have to happen with JS, and things aren't quite configured correctly, but ideally on the left-hand side here, I think I just ran it from the wrong folder is all. This would be running Webpack watch. Up here it would be running Webpack unit test, or running unit test on my app. Down here it would be running Karma integration test. And I'd be able to have all three windows open and all those things running at the same time. And if I write some TypeScript code and save the file and it fails a unit test, I would see some red scroll by, and that would be glorious that all happened for me. Let me try to go to, see if I can get this working real quick. What folder am I in? This might be a little bit better. Yeah, over here is the Webpack watch. Over here we're still failing, so, but you get the idea. The command that does all that for conemu would be to run conemu with this following run list. In one window, I want to run npm run watch. Then in another window, npm run test watch, put that in a new window that's split horizontally, that's sh. And then npm run karma unit test in a new console that's split vertically. So it takes this side that was split horizontally and splits it vertically, and I get that window in the bottom right. Fascinating, right? I'm going to skip over a few slides here related to client code. I do want to point out, look, Bower is dead. Just use npm or yarn for client-side stuff. Even if you're just, if you're not, you're not writing a Node.js application. I understand. You're just using Bootstrap and jQuery. But all those front-end dependencies now, they're all in npm. So forget about these other package managers. npm or yarn will do just fine for you to download those and manage those. And NuGet for anything .NET related. I was not a big fan. I tried to like TypeScript for so long, and it wasn't until I'd say beginning of 2017 where I thought it really started to mesh well with the way JavaScript programmers wanted to work, and I really started to enjoy TypeScript, and now I do encourage people to take a look at it if they haven't looked at it yet. TypeScript has finally embraced the Node ecosystem. You can npm install a TypeScript compiler. The TypeScript compiler will do things like use the node module resolution strategy in the way it tracks directories and looks around. And it understands the node modules folder, so when you npm install other things, and inside of TypeScript you import them, it knows to look in there. This paths configuration option, so this is a TypeScript config file. The paths option is very useful when you want to go and define your own custom sort of modules folder. So I don't want to be forced to put my TypeScript files in a specific folder. I want to be able to put them someplace and tell TypeScript, look, if something doesn't import foo from bar, then one of the places where you should look for something called bar is in the client/script folder. So go into there and look for it, and that's what that would do. So TypeScript has come a long way. But most projects where I have to do any amount of TypeScript or JavaScript, I'll have the project open in 2 editors, Visual Studio for C# code and Visual Studio Code for TypeScript and ES 2015. It is still by far the best editor for TypeScript and JavaScript code. So if you haven't tried Visual Studio Code for JavaScript, you really should use Visual Studio Code for JavaScript. It does a much better job and produces fewer false positives than Visual Studio. I think of www.root as my bin folder when I'm using TypeScript. So where do I compile things? Where do I output them? Well, place them into www.root. All the bundled and minified stuff. So it's like a bin folder for me, but for JavaScript and TypeScript. Testing. Just a quick word on how many test projects should you have. So I've worked on projects where there's a web project and a core project and some stats calculation project, all these things that are separated out. And people will say, hey, we need a test project per production project, which to me is crazy because now I have to go looking everywhere for tests. To me, a project, typically when I want to create a new project, is because I want to create a new unit of deployment, or I want to deploy that code differently than the code that's in other projects. And to me, unit tests don't have to be deployed, you just have to execute them. So if you want to put the unit tests for 3 different projects that are part of a system on the same test project, that's fine. I like using XUnit. There's various options now for .NET Core, but I still feel that XUnit is the best test runner and the best test language for writing unit tests. So it's low ceremony, has a good vocabulary, and it's my preferred testing framework. I try very hard to avoid mocks. So I'll tell you a little story about how this came around. I started trying to do test-driven development around 2004, and I did it the traditional way. So write the test before you write the code. Then you do red-green refactor and follow all those steps. Did that for years. And then I felt like I got to the point where I was comfortable writing testing code without necessarily writing the test first. So I started not following that as religiously, and that was fine. Things still turned out fine. But I was still trying to think about unit tests. How do you unit test a controller? Well, the only way to unit test is to make sure you isolate that controller so it's not working with any of your real production services. So you're giving it fakes or stubs or mocks to that controller. And then, it's writing a lot of code, but it seemed to work pretty decent for C# anyway. Then, first big AngularJS project came along, and I tried to follow that same philosophy. AngularJS controller, how am I going to unit test it? Well, I'm going to fake out and mock out all the services that get passed into that controller. So me and a couple other people on this team, we had this huge, huge pile of unit tests for our Angular controllers, and it was so frustrating because every release, something would break. Unit tests would pass, something would break. And that's when I realized that trying to mock up things, create mock services, and write the unit test, you're just programming in expectations to your unit test that it should behave the way you think it should, which is not really what I want out of a unit test. So I started using this different approach on that AngularJS project years ago, and I said, look, what if we didn't mock any service except HTTP? What if we wrote tests that called into the controller, and if the controller called into the service, that called another service that eventually did an HTTP call? What if it went the whole way to the HTTP layer and we just mocked out the data at the HTTP layer? And what I found was we wrote 30% less test code. We actually found bugs when people checked in bugs into the project before they got to production. And all of a sudden, it just kind of changed my view on testing a lot that year. And I started thinking, when I write a test now, I'm not necessarily going to think of it as a unit test. Traditionally, at least to me, a unit test, the reason we wanted to isolate things, so if someone checked in a bug, at some low-level system component that it didn't break all 1,000 or 200 or 5 unit tests that are in the project. It only hit, you know, an isolated area of my unit test that was testing that feature. But to me, it's not worth it. I would rather write, let's say, 10 lines of test code that could fail for any number of reasons inside of the system, because to me that's still an effective test. It provides a lot of value for me, and I only had to write 10 lines of code, and I didn't have to mock a bunch of stuff up. Where am I going with this? Well, it turns out with ASP.NET Core, there's a couple interesting things you can do. One, if you look in the Microsoft repositories, you'll see they have a NuGet, specifically when they write unit tests. Like, how do they test middleware? Well, they use this thing called the ASP.NET Core test host. The ASP.NET Core test host, kind of like the thing we used to do with Web API a few years ago, where you could host the Web API in memory. The ASP.NET Core test host provides me an API where I can say, let's create an application with this startup and this middleware and these services, and then send requests into it that don't actually travel over the network. So everything happens inside of memory. And you can find tests inside of the Microsoft repository that look like this. Let's create a server, so behind the scenes that's using this test host. And we're going to pass in some options for the cookie authentication services that the login path should be here. We're going to send off HTTP messages to that server. They're just really traveling through memory. And it's going to go the whole way through the system. It's going to travel through all my middleware, use services that are configured in there, and I want to see that it comes out with the status code and this header and so forth. Another example, excuse me, down here at the bottom. Create a server, use that server to create a client, use that client to send off a GET request. Here, I just want to make sure I get back a status code. To me, those 3 lines are beautiful, because of those 3 lines, if that test passes successfully, I have a higher degree of confidence that the system is going to work versus having 20 tests, one that isolates the logger and one that isolates the middleware and so forth. But this is my personal philosophy and opinion. You can differ. So where can you mock things out? Well, again, I like mocking things out of the data layer. So you have to have the abilities to switch abstractions between, let's say, something that talks to Cosmos DB or MongoDB with something that just holds data in memory. And if you're using Entity Framework Core actually has this thing called the in-memory provider. So it simulates SQL Server, or simulates a database just by holding data in memory. And no, it's not going to catch errors like if you try to insert records with duplicate primary keys. It doesn't enforce database constraints, but it is a mock or a fake data layer that if I configure the Entity Framework to be in memory, I can use all the rest of my services inside of an application with that test host and fire off requests to do something like save this new user or save this invoice or edit something. Everything happens in memory. And I have basically an integration test, but it's not an integration test where I have to mess around with the UI. It's an integration test that goes through all my middleware, all my services, exercises everything right up to the actual database layer. And to me, that means writing a lot less test code and having better bang for the buck for the number of lines of test code that I have. So using the EF Core in-memory provider, pretty straightforward. Just have to say to use an in-memory database and follow a couple constraints when you're instantiating this thing, and it's good. So more integration tests, fewer unit tests. That's kind of my current motto for some scenarios. Not everywhere, but heavy business logic, I still like to isolate and test that, have specific unit tests for that. But to me, not having to test a controller in isolation is beautiful, because most controllers are, let's face it, relatively simple. I would rather test all the middleware and the controller and everything down to the database layer. C# code. So one of the things that people are doing with ASP.NET Core, I've realized, is they're taking the advantage that ASP.NET Core can execute on Linux. And so when they deploy, they pick Linux VMs or Linux app services, and they save 20 to 30% on that server because they're not paying for the Windows license. But there's always some little hiccups. So some things that we have run into. And I should back up and say, if you're going to do that, so to me, let's talk about Docker for a second. To me, one of the advantages of using Docker containers is that I can develop on my machine, which is Windows, but I'm executing code that is in the production environment, which is Linux. And there's a big advantage to that, because I can catch problems sooner. Is that making some sense? problems like this. So just the littlest things bite you. In C# code, you hard code new lines into an application. But new lines are really different on Linux and Mac versus Windows. So instead of hard coding /r/r/n, use environment.newline. It's amazing how many people hard code paths, right? So I need to build the path to /users/temp/ and then I have the file name. Or I have some base folder name that's configurable and then I have my file name. How do I put them together? Well, I could just use this string plus / this string, except that /, right? It's different on Linux versus Windows. The proper way to do that, use path.combine. Also be aware that environment variable names can be different between the two environments. So those are the types of little things that you can catch if you're using Docker to actually develop on Linux. And then finally, me personally, I despise the async suffix on methods. I think having the word async here and having the word async here is just too much async. So even though the Microsoft recommendation is that async methods should have the async suffix, I don't do that. And to me, I felt justified when I read this quote from the inventor of C++. He said, for new features, people insist on loud, explicit syntax. And I said, yeah. When async first came around, it was scary. So we're just going to use the async word everywhere. Make sure people are aware this is async. But now it's an established feature. People want a terse notation. And I think I personally have reached that point. I wish we could just have everything be async by default and not even have those keywords there. But that's a pipe dream. So I think it's fine not to use the async suffix. But you can differ with me. And that's all I have for you. I thank you for attending. This is my email address if you have some questions. I think we're out of time. I'll hang out and answer questions. Have a good afternoon. Thank you.